Okay, hello everyone. So this video we're going to solve this non-homogeneous differential equation. We want to find its general solution, which we do need the complementary solution plus a particular solution. So to find the complementary solution, we do need to solve the homogeneous equation. And I'm going to do this rather quickly because I want to get to the other part. Solving this, we know the forms of solutions are of e to the rx, taking each derivative up to the third and then plugging them in, we get the characteristic equation r cubed minus 2r minus 5r, minus 2r squared minus 5r plus 6 being equal to 0. Using synthetic division, we can show that 1 is a solution, so we know r minus 1 will be a factor, and then we need to find the other factor that will multiply to 0. Using the coefficients, we can show that it factors, and coefficients of that polynomial will be 1r squared minus 1r minus 6, and that fully factors to r minus 3 times r plus 2 being equal to 0, which gives us three values of r1, r2 equals 3, and r3 equals negative 2. And this is nice because this gives us essentially our complementary solution, but also gives us three independent solutions. Our y being equal to e to the t, y2 being equal to e to the 3t, and y3 being equal to e to the negative 2t. But really, we wanted the complementary solution, which is y sub c of x. Sorry, I used t instead of x, so used to using t's, but we are using x's for this problem. So the complementary solution is going to be some constant times e to the x plus c2 e to the 3x plus c3 e to the negative 2x. And then we need to find a solution, the non-homogeneous, to get a particular solution. And to do that, we start off by noting that we want a solution that kind of fits this form of really a quadratic equation times e to the negative 3x. But before that, I'm going to make it a general, like, let's say it's going to be of the form u of x times e to the negative 3x. That may help in some calculations. So doing that, we will find the derivative. We do got to find the derivative. Finding the derivative, we have to use the product rule. And so first, the product rule, this is going to be u prime times e to the negative 3x. And then taking the derivative of e to the negative 3x will give us negative 3 times u e to the 3x. And then simplifying that, we will get e to the negative 3x times u prime minus 3u. So for the sake of time, I'm also going to kind of simplify the other derivative, but this derivative also, you will need to use the product rule. We take the derivative of the u prime and minus 3u, and then add it to the derivative of e to the negative 3x while leaving the parentheses stuff alone. But you will end up with for the second derivative, once you simplify all that, you will get e to the negative 3x times u double prime minus 6u prime plus 9u. And then similarly, for the third derivative, again, using the product rule, and then simplifying, you will end up with e to the negative 3x u triple prime minus 9u double prime plus 27u prime minus 27u. And then we have to plug all this stuff into this differential equation, which I will attempt to do in a very neat way, hopefully. E to the negative 3x times u triple prime minus 9u double prime plus 27u prime minus 27u minus 2 times y double prime, and y double prime is e to the negative 3x times u double prime minus 6u prime plus 9u minus 5y prime, and y prime is e to the negative 3x times u prime minus 3u plus 6y, and y is just e to the negative 3x times u. And that is equal to e to the negative 3x times 32 minus 23x plus 6x squared. Okay, so now that we've plugged everything in, we do need to do some simplification. Notice e to the negative 3x is a common factor of both sides, so we essentially can divide all that out, right? And then we can combine some like terms, right? There's some u double primes, some u primes we can combine. So me stating that is mainly so I can just tell you and jump to the simplified version. And the simplified version ends up being u triple prime minus 11 u double prime plus 34 u prime minus 24u being equal to, and I'm going to write the polynomial with the highest power term first, mainly just because I like to do that, but you don't have to. And then this makes it nicer, so we can solve this without having to use all the e to the negative 3x stuff. This was why I offered a solution of this form. Easier to kind of keep track of things. But you also didn't have to do that. It just is a bit more tedious, or can be. But in this form, we now can do the whole undetermined coefficients, and we can say that we are looking for u, I'm going to say u, particular u, of x is going to be in the form of a quadratic ax squared plus bx plus c. And then we take the derivative. U prime of x is going to just be 2a plus, oops, don't forget the x, 2ax plus b, and then u double prime is going to be 2a, and u triple prime is just going to be 0, since 2a is a constant. So that works out nice, and we just need to now plug our result into here, our differential equation here. U triple prime is 0 minus 11 U double prime, which is 2A, plus 34 U prime, which is 2AX plus B, minus 24U, which is AX squared plus BX plus C, and that will equal the 6x squared minus 23x plus 32. So from here, we want to rearrange terms to get essentially it in the form of a quadratic, something x squared plus something x plus 32. So doing that, we get negative 22a plus 68a x plus 34b minus 24ax squared minus 24bx minus 24c. And again, that is all equal to 6x squared minus 23x plus 32. And rearranging this stuff, we'll have negative 22a plus 68a minus 24b x minus 24ax squared, and I do have my constants here, plus 34b, and one final reorganization, 24ax squared, because I want it to match kind of the right side, 68a minus 24b x, then plus negative 22a plus 34b minus 24c, and again that's equal to 6x squared minus 23x plus 32. And finally, this helps me because now I can say the constant negative 24a has to be equal to the constant in front of the x squared term on the right side. So that just means negative 24a has to be equal to 6, which means a has got to be negative 1/4. Yay, that's nice. And then 68a minus 24b has to be equal to the constant in front of the x term, which is negative 23. And since a is negative 1/4, I'll just have 68 over 4 with a negative minus 24b being equal to negative 23. I'm just jumping to the solution again because I will leave you to do the arithmetic part if you like. When you solve for b, you just end up with 1/4. And then finally, the constant stuff, which was negative 22a plus 34b minus 24c. That all has to equal the constant on the right side, which is 32. Plugging in the a and the b, we will have 22 over 4 plus 34 over 4 minus 24c being equal to 32. Again, I'm just going to jump to what c ends up being, simplifying to negative 3/4. So that's great because now we know our particular solution in the form of u, so u sub p of x is equal to let me factor the negative 1/4 out. Negative 1/4, whoops. Negative 1/4 times x squared minus x plus 3. And then, if you recall that our y sub p was in the form u of x times there we go. I lost my place. U of x times e to the negative 3x, right? So that just means our particular solution is going to be e to the negative 3x negative over 4 times x squared minus x plus 3. And that almost does it, except I did say I wanted the general solution. But that's just one final step. That's just, again, remember that's, we are in terms of x, so it's going to be the complementary solution plus the particular solution. And that, for us, is c1 e to the x plus c2 e to the 3x plus c3 e to the negative 2x plus our particular solution. And our particular solution is minus e to the negative 3x over 4 times x squared minus x plus 3. And that, my friends, is our general solution.